For this question, the particle starts from rest and move in a straight line so that t second after passing through a fixed point O. Its velocity is given with the equation of v equivalent to 5 bracket 1 minus exponential of negative t. So the first question asks you to find the velocity of the particle when t is equals to ln of 100. So for part A, when t is equivalent to ln 100, can be written as 5 in bracket 1 minus exponential of negative ln of 100. Okay, to continue with this, you can actually write it in the form like this, where you have 1 minus exponential of ln of 1 over 100. Because you bring the negative up, it will become power negative 1. Okay, 100 with power negative 1 will give you 1 over 100. Okay, so with this you can see that exponential and ln can be cancelled off one another, and hence this part, this particular part, you will be getting 5 times with 1 minus 1 over 100. So with this, you press your calculator, you will be able to get the answer as 4.95 meter per second. That's for part A. We proceed to the second part. State the value of V, when t becomes very large. Okay, look at the equation of V, where you have for V, velocity is equivalent to 5 bracket 1 minus exponential of negative t. Okay, when t value becoming very large, so if you look at this particular part, exponential of negative t, let's say if the t value is equivalent to 1, so exponential of negative 1 will give you a value of 0.3678 blah 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 blah. Okay, so if the t value is equivalent to 10, exponential of negative 10 will give you exponential of negative 10 will give you 0.00000454 and so on. Okay, continue if you want to try exponential of negative 12. Alright, exponential of negative 12, it will give you 0.0000000614 blah blah blah. Okay, as you can see, when the t values is becoming bigger and bigger from 1 to 12, the values of e actually getting smaller. That means exponential of negative t is actually getting smaller and smaller, and hence it will be approaching to 0. Approaching to 0. And then go back to your question again. The question says that velocity is equivalent to 5 1 minus exponential of negative t. So when this particular part is approaching to 0, hence you will be getting only 5 1 minus a value which is very near to 0. This is 0. So what you will get here for V, it will be approximately equivalent to 5. Moving on to the next part of the question, you have to find the acceleration of the particle when V is equivalent to 4. Since this information is given from the question, so for part C, the first thing that you can do is put 5 1 minus exponential of negative t equivalent to 4. Hence, with this, you will be able to find the value of t. Alright, So let's move on. 1 minus exponential of negative t will give you 4 over 5. Hence, negative exponential of negative t will give you 4 over 5 minus 1. And then you will be able to get negative exponential of negative t equals to negative 1 over 5. Since both sides also having negative, so both can be cancelled off one another. So to bring the t down, what you can do is you ln the both sides. So adding ln to the both sides, you will be able to get exponential of negative t equivalent to ln of 1 over 5. Okay, so with this can be cancelled off. So negative t will be equivalent to ln of 5 to the power of negative 1. We can also write it this way. Again, continue with this. According to the logarithm law, I can always bring the power forward, where it can be written as negative 1 or negative ln of 5 equivalent to negative t. So t can be written as ln of 5. You can leave your answer this way, or you can calculate the value in decimal, both way. But it is best to leave your answer in the exact value. Okay, now since we have the value of t, so it will be easy for us to get the acceleration. Okay, take the equation of v, okay, differentiate it, you will be able to get acceleration equation. So acceleration can be found by dv over dt. So 5, we're keeping it. So differentiate 1 will give us 0. Okay, negative exponential of negative t, differentiate negative t will give you negative 1. Hence, the derivative of v is equivalent to 5 exponential of negative t. So now when t is equivalent to ln 5, okay, when t is equivalent to ln of 5, a will be equivalent to 5 exponential of negative ln 5. Okay, so with this can also be written as 5 exponential of ln 5 to the power of negative 1. Okay, or you can also write it as 5 exponential of ln 1 over 5. Okay, so either you stop from here, this equation, or stop at here. Okay, you can also cancel off the exponential and ln away. So lastly, you will be getting 5 times with 1 over 5, and then your answer will be 1 meter second square. Okay, lastly, let's look at how to sketch the velocity time graph for the motion of the particle. So if you read the question properly, it says that, okay, it is starting from rest, which means that when t is equivalent to 0, v is equivalent to 0. That's the first information given. And then it moves in a straight line, okay, it moves in a straight line that t second after passing through O. So this is given. And from part B also we says that when t becoming very large, that means t is getting very big number. Okay, so maximum value, okay, of velocity will be 5, which means that, okay, the value of v will never ever exceed 5. So what you can do for velocity and time graph is, it is just a sketch, okay, with the velocity at the y-axis, with your t at the x-axis. It starts from 0, 0. When t is equivalent to 0, v is equivalent to 0 as well. And then when t is getting bigger and bigger, okay, the value of v, okay, will be maximum at most is equivalent to 5. Hence, at this particular line, okay, will be your maximum line, I would say. So when you are sketching, so from 0, 0, okay, it move and go maximum to 5. Alright, that's your graph.